Hello, in this video we're going to learn how to draw the VSEPR structure for phosphorus trichloride. First thing we need to do is get the Lewis dot structure. We'll identify the types of atoms we have. We have phosphorus, we have chlorine. Phosphorus gives us 5 valence electrons. Chlorine gives us 7 valence electrons. We have 1 phosphorus giving us 5 electrons plus 3 chlorines giving us 7 electrons for a total of 26 electrons in our bank. We want to place the less electronegative phosphorus in the center. We'll do a spoked wheel with some chlorines around the outside. We had 26 electrons to work with. We just made 3 bonds worth of electrons that we used. We have 20 electrons left over. We'll begin filling out the octets on our terminal atoms. We had 20 electrons to work with. We just used 6 electrons 3 times. We're going to have 2 electrons, 1 lone pair left over. That guy is going to have to go in the center. If we draw our bond dipoles, we're going to be pointing outward because we put the less electronegative atom in the center. There are our bond dipoles. If we calculate the steric number, or count it more so, it's the number of atoms attached to the central atom and the number of lone pairs. So we got 1, 2, 3 atoms and a lone pair for a total steric number of 4. And then we need the number of lone pairs on the central atom. He's got 1 lone pair on that central atom, so that's going to be 1. We come down here, we identify our steric number, we identify the number of lone pairs. We are here. Trigonal pyramid, that's going to be our molecular geometry. We need to interpret this picture for our case here. So we're going to have phosphorus. Straight up, we're going to have our lone pair. One of the chlorine is going to be in the plane. One of the chlorine is going to be coming out of the plane at us. And the last chlorine is going to be going into the plane of the paper. We need to identify the electron geometry. That is going to be the first one here, tetrahedral. Tetrahedral. And the molecular geometry is going to be trigonal pyramidal. Which, if we think of these 3 here making like a triangle, each one is connected to the phosphorus. There's like a triangular base on a pyramid, so trigonal pyramidal.